Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 1.6, Problem 34. This is Section 1.6, Problem 34. It says Bob and Linda have an in-ground pool that is 20 feet by 40 feet. They have a concrete deck all the way around the pool that is 5 feet wide. What is the area of the concrete deck? So first of all, let's get a picture of what this looks like. So Bob and Linda have a pool that is 20 by 40. So here's their pool. 20 on one side, 40 on the other. It's 20 feet by 40 feet. This is a pretty common size for an in-ground pool. And then they have a concrete deck around the pool that's 5 feet wide. That's also fairly common for people who have an in-ground pool. So it's 5 feet. That's the width of the concrete deck. And we want to know what's the total area of the concrete deck. Now there's more than one way to solve this. You could make that concrete deck area into 4 separate rectangles and find the area of each one and add them together, and that will work. But that's not the easiest way to do it. First, let's figure out what's the overall dimension of the concrete area. So coming across the pool is 40 feet. So if I go 40 plus 5 more, it's 45 from the starting edge of the pool to the edge of the concrete. Well, if I go 5 more feet to the left, it's 45 and another 5. That's 50. So the distance, the long distance of the concrete length is 50. So let's do the same type of computation for the shorter length. So from one edge of the pool to the other is 20 feet. So if I go 20 plus 5 more feet, 25, I'm at the edge of the concrete. Starting from one edge of the pool, I'm 25. So if I go 5 more, I start 5 feet back, it would be 5 plus 20 is 25, plus 5 more is 30. So the shorter length of the concrete area is 30. So now, let me compute just the area of the concrete. Forget the fact that there's a pool in the middle of it. I just have a big rectangle here that's 50 feet in length and 30 feet in height. So, concrete plus pool base times height. The base, the long distance, is 50 times the height, the shorter distance, is 30. Now those are big numbers to multiply, but remember the trick for multiplying big numbers that have zeros from some of the previous problems. Initially, let me just ignore the zeros and I'll just look at 5 times 3. That's a number I can do in my head. 5 times 3 is 15. Now, how many zeros did I ignore? 1, 2. So I'll take the answer of 15 and put 2 zeros after it. So the total area, concrete and pool, has an area of 1,500 square feet. So now, let's find the area of just the pool and subtract it, and then we'll have just the area of the concrete deck. So just the pool, I'll do in blue for the water in the pool. So concrete plus pool was 50 by 30. Just pool is 20 by 40, or you could write 40 by 20, it wouldn't matter. Again, I'm doing base times height. You could figure that I wrote the height first, but you can really multiply in either order and get the same answer. And it's the same type of trick that I use for the total area there. I have some big numbers to multiply, but because of the zeros, I can just ignore the zeros, focus on the non-zero digits of 2 times 4, and that's 8. Then I can take the 8 and put the 2 zeros back that I ignored. So just the pool on its own is 800 square feet. So if I take the total area of concrete plus pool, subtract away what's only pool, I'll have just concrete. So I have 1,500 for the total concrete plus the pool, minus 800 for just the pool by itself. So now I can do that subtraction. 0 minus 0 is 0. 0 minus 0 again is 0. 5 minus 8. The 8's too big to subtract from the 5, so I'll borrow from the 1. Cross it off, reduce it by 1, goes down to a 0. Add a 1 to the 5 that I was subtracting from, making it a 15. Now 15 minus 8 is 7. So the answer is just the concrete is 700 square feet. And I'll abbreviate the units of measure. SQFT for square feet.